I'm going to show you here how you can use web-based applications to complete your 6.2 lab. So the first thing that we're going to do here is that we are going to simulate some race times for these 4 athletes. It tells us here that the times for each student are approximately normally distributed, and then it gives us the mean and standard deviation for each student. So here we can use on random.org what's called a Gaussian random number generator, and that's going to generate numbers that follow a normal distribution with a specified mean and standard deviation. And I'll provide the link for the specific random number generator in the assignment. So if we're looking to randomly generate, here it says 50 different times for Will, I want to generate 50 random numbers, and I have the mean for Will is 9.8, and I have the standard deviation for Will is 0.9. I'm going to change my significant digits. I don't need quite 10. I'm just going to change it to 4. And then I want to put my data in just one column, and then I can go ahead and say I'm going to get my numbers. So now that I have these numbers, I need to copy and paste these into a Google Sheet. So I'm just going to copy them, go to a Google Sheet, and I still have some data in here. Let me clear that out. And I'm just going to paste that into the first column in the Google Sheet. So that's the simulated times for Will. If you're working with a partner, you want to make sure that you're sharing the Google Sheet because eventually we're going to combine all of their race times. Now I'm going to go back to random.org, and at the bottom of the screen I can hit go back, and it'll take me back to my number generator. I now want 50 times for John. John has a mean of 10.3 and a standard deviation of 1.1. So I'm going to type that in, 10.3 for the mean, standard deviation of 1.1. And then I'm going to keep 4 significant digits. I'm going to keep one column. I'm going to get those numbers. Now again, I want to put these into my Google Sheet. So I'm just going to copy those, paste them into the second column of my Google Sheet. Then I go back to random.org again. Whoops, and at the bottom I can say go back. I'm now going to generate 50 times for Eric, who has a mean of 9.5 and a standard deviation of 1. Again, 4 significant digits, leave it in one column, get those numbers. So now I'm going to copy Eric's simulated race times into the third column of my Google Sheet. And then finally, I'm going to go back to random.org, go back to the number generator. I want to simulate 40 times for Ryan, or I'm sorry, 50 times for Ryan. So mean of 11.8, standard deviation of 1.4, and then I can go ahead and get his simulated times and copy and paste those into the fourth column of my Google Sheet. Once we're here, I can answer question 2. I can find the mean for Eric, who is in column C here. So I can find the mean of column C, and then I can count up how many of those times are within this 9.5 plus or minus 1 second window. So essentially 8.5 to 10.5. Just keep in mind that these are in scientific notation. So this time here, where it's the plus 0, 0 is really just 8.61 seconds. But over here, this would be 11.3 seconds or 10.2 seconds. So just make sure you're remembering to move that decimal. Then when we get down to question 4, you're going to make a histogram for each of the athletes. And so it's easiest to do that in Staplet, more so than using Google Sheets. So if I copy all of my times for my first athlete, and I go to Staplet, I have one quantitative variable. So I would select that from the home screen here. I'll go back to staplet.com real quick. So here where it just says one quantitative variable. And then I'm going to input my data and hit begin analysis. I want a histogram, and then I can sketch this histogram here for my first athlete. And then I would go through and do the same for the other columns to sketch those histograms. Then here in the lab, just making a prediction as to what I think the combined distribution is going to look like and making a prediction for mean and standard deviation. And then I'm actually going to combine all of their times. So I can do that in another column in my spreadsheet. And I'm just going to say here that I want this cell to be equal to A plus B plus C plus D. So I just put in the addition symbols. I clicked on each row to put in the A, B, C, and D, or you can type it in as it appears here. When I hit enter, it's just going to do that first cell, but then I can drag this down. And then it will add for all of those individually. So now these are, my combined relay times for each of the 4 simulated individuals. So that's really going to be the equivalent of list 5 over here. So A is list 1, B is list 2, C is list 3, D is list 4, and then list 5 is that combination. So you'll calculate the mean, variance, and standard deviation, or really just mean and standard deviation for each list, square it to find the variance, to fill in these numbers, and then you'll fill in the general rule. When you move on to part 2 here, this time you are randomly generating heights for men and women that follow a normal distribution. So you can go back and use your Gaussian random number generator here. You're simulating 50 men and 50 women, so still 50 numbers. Then you're going to type in the mean for the men, standard deviation for the men, get those numbers. You'll then repeat with the mean for the women, standard deviation for the women, get those numbers. And then you'll follow along with the rest of that part of the lab. And then part 3 is bonus. So if you want to stop at the bottom of this page here, once you find correlation, then you're done. You can complete your lab and potentially get full credit. If you choose to do the bonus, it would be starting on part 3. If you work with a partner, you only need to turn in 1 copy of your lab. Just make sure both of your names are on it. So you do not both need to submit through Schoology, just one through Schoology, and then I'll take care of the grade transfers in the gradebook.